It was like no other time. It was like history in a hurry, eager to cram so much of its knowledge into a quarter of a century. The world may never see the likes of it again. The talent, the intensity, the achievement. It was the aerospace adventure that the accumulated momentum of man chose to assign to the second half of the 20th century. It truly became the most fascinating business in or out of this world.
We were, of course, absolutely elated with the recovery of Discoverer 13 capsule. We had been trying for months. We'd had 11 attempts prior to that, and this was the first successful recovery of a man-made object from space. It put the Air Force in a position to proceed with programs that it had been planning and thinking about for a good many years. It put us on the road to space. It was a long road, and it took a lot of hard work. We actually didn't start much hardware activity until the early 50s at a very low level of effort, because not very many people thought that a long-range ballistic missile was feasible because of the weight of the warhead and many other factors. There was evidence that the Soviet Union had initiated a major effort to develop an ICBM. We did not have very much hard intelligence. There was sufficient evidence that this probably was a fact, and it was at this time that Trevor Gardner came into the Pentagon. He was given the job of heading a study group to review the entire strategic missile effort. Their report came out in February of 1953. The report stated that it was feasible to develop an ICBM having a range of 5,500 miles and 1,500-pound warhead with a yield of 1 megaton should make this an extremely effective strategic weapon in the sense of having great deterrent capability. It became obvious, however, that the Russians were working very hard on a long-range ballistic missile, an ICBM. Through GE as a contractor, radar was installed in Turkey. It was within the few months that we had hard evidence that indeed the Soviets were, in fact, carrying on a major effort to develop a long-range ballistic missile. An ICBM program had been authorized. I was given top priority in selecting the people that I considered to be most qualified to work in a program of this kind. A considerable number of academic people from universities entered into the program. We received the support from top management in every major company that was involved in the Atlas program. I recall a letter I got from Lapierre of General Electric in March of 1955 in which he indicated the complete support of GE and their desire to be considered as a nose cone contractor. We were not the only ones working around the clock. So were the people in industry working around the clock. And it was just that kind of a program. Everybody had such a dedication and felt that this was so important that time and number of hours meant nothing. The missile and space period of the 1950s and 60s are undoubtedly the most exciting and challenging years of my life. We brought to fruition the work of the pioneers Goddard and others. We developed the ICBM, the communication satellite, weather satellite, and we also put a man on the moon. Our success was made possible because we mobilized the resources available to us in this country. The next 20 years, I'm sure, will be equally as dramatic as the last 20. And who can even guess what the next 50 will bring?
It was here at the Malta test station, about 20 miles from Schenectady, New York, and in this test pit number 1 where we stand, that GE started the very first rocket engine tests in 1945 in pit number 1 behind us, which started us in the rocket era. From there we went right into the ballistic missiles and eventually right into the space age. At Malta, we tested not only the rocket engines, but also the complete missiles, including the guidance and control. After 10 years of this kind of work, we had gained a vast amount of experience, had many talented people and resources which were ready for the next phase. And we were in this business to stay.
With the Hermes work beginning to phase out, the company sought to apply this experience to a new challenge. Group executive Jim LaPierre positioned GE squarely in the forefront of responding to a new national need. Air Force Brigadier General Bernard Schriever had been named to command the Western Development Division and the Air Force's priority program, Atlas. Its goal, an operational intercontinental ballistic missile before the end of the decade, just 5 years away. Schriever's job, assembling a team to meet this goal. LaPierre selected George Metcalf from Syracuse's Engineering Services to lead the GE nose cone proposal team. Engineers immediately went to work on the Atlas nose cone, the vehicle designed to protect the missile's payload and instrumentation during the critical re-entry into the Earth's atmosphere. In total secrecy, Metcalf and his people began their work. Adding others as they could, the proposal team met their 6-week deadline and submitted their approach. After submittal, the waiting started, while the work continued. The waiting ended, and the new Special Defense Projects Department began on May 31st, 1955, with the award of a contract for the Atlas nose cone. Temporary headquarters were established at Campbell Avenue as parallel efforts in recruiting and site selection began, while the technical work continued. More than 20 cities throughout the U.S. were considered for department headquarters. Duff Greentree and his people were responsible for identifying the best location for SDPD operations. The Philadelphia area best met the established criteria and was selected. An A&P warehouse located at 3198 Chestnut Street had the space and flexibility the work demanded. On December 22, 1955, the announcement was made that Philadelphia would be the new home for the nose cone project. Plans were quickly made for the speedy transfer of the people and programs of the new department.
Well, in the early years, it was hectic. The people were coming on board far faster in our ability to accommodate them within the one building, or faster in our ability to get other tenants out. As a consequence, it was necessary to get additional facilities. When we rented the D Street facility in 1956, we told the realtor that we were looking for a one-story building to run a shock tube in, and the main objective was to get the building where we could blow the roof off in case the roof blew off. We did need something, type of facility where if there was a blow, it would blow straight up, blow the roof off possibly, and not do any damage in the area.
The massing of men, materials, and machines proceeded. Testing programs, scientific research, new manufacturing concepts, all called for major advances across a wide technological spectrum. Working the re-entry riddle, theoretical and analytical studies continued. The heat sink approach, using a copper shield to absorb the re-entry heat, had been selected by the Air Force industry team as the solution for the first generation re-entry vehicles.
We were engaged at the time in the first approach was the so say the rational, calculable approach, which means to make a copper nose cone which one could reasonably be sure of would survive, and in a very limited environment you could calculate most of the parameters. For select first GE configuration, which was the first national configuration, which we thought would survive the re-entry environment. At the same time, it also seemed sensible, since the copper had a very limited capability, to go to a much more innovative approach, namely that of saying the silly thing wants to melt, let it, and put enough stuff on it so there would be something left to survive. Dubbed that the ablation approach, and we started work almost at the same time that we designed the copper nose cone. We started a major research program on ablation, and that, of course, eventually turned out to be the final approach to the reentry problem.
General Manager Metcalf strengthened the organization with several key additions. The twin lures of creative freedom and challenging technical work attracted a cadre of new professionals. The department continued to grow and change. Now part of George Haller's Defense Electronics Division, SDPD added Naval Ordnance Department and became Missile and Ordnance Systems Department, while continuing to acquire new business and new customers. Less than 2 years old, the department now had more than 2,000 employees and locations in a half-dozen states. Even as the initial reentry vehicle, the Mark I, was being fabricated, a System F for Flexibility Design Study Team under Howard Whitner was working on a design that would permit a common internal structure for both the R&D and operational programs. This goal was achieved and designated the Mark II, a program destined to be of immense importance to the nation's efforts in space. The Air Force would shortly establish a space laboratory program to use the free ballistic flight through space during the time between booster separation and re-entry. During this 25-minute period, various scientific experiments could be conducted and hardware flight tested. The Mark II also carried a recoverable data capsule, which contained data and instruments from the space portion of the mission. But others were hard at work, too. As work continued on the Mark II, other test programs were started on new high-performance advanced vehicles, all of which added to America's arsenal of knowledge. The early years had their share of spectacular failures and disappointments, but the lessons learned from these problems and a continuous determined effort led to success. The progress was steady and sure as the business grew. The creation of NASA in July 1958 gave solid evidence of increasing government interest and support. Just 1 month earlier, a data capsule from a Mark II reentry vehicle was recovered, the first payload ever recovered from space. It was one of an impressive list of GE firsts, providing proof of our growing sophistication and capabilities.
The late 50s represented the beginnings of the space age. We ourselves at that time were heavily involved in the reentry systems business to solve the reentry problem coming in from outer space with a vehicle. During that period, we achieved a very impressive list of firsts, and we were involved in a very broad spectrum of technologies. And this put us in a strong position for the more sophisticated work of the 60s as it approached us.
Work was proceeding across many fronts. Burlington and Pittsfield continued to contribute in support of the Atlas and Thor programs for the Air Force and Tartar for the Navy. The department grew with the addition of the Mark III contract, changed its name to the Missile and Space Vehicle Department, and announced a new general manager, Hilly Page, formerly head of the nose cone section. The firsts continued to accumulate under the new leadership. Recovery of data capsules was becoming more routine. First photographs from a space vehicle in flight at altitudes of between 125 to 300 miles provided a new and dramatic perspective of Earth. Successful flights of 5,000 miles and more were ample evidence of growing effectiveness and capability by the skilled Air Force industry team. Advances in the space laboratory program led to the first three-axis individually stabilized space platform. On a July 59 flight, a camera in the data capsule took pictures of Earth. 1 month later, this same technique would be repeated, enabling construction of a composite photograph of 1/6 of the Earth's surface. The department had made several key contributions to General Schriever's major goal of just 5 years ago. By September 1959, the Atlas program was pronounced operational. Working the 5,000 and 10,000 mile production lines, the Air Force also deployed the Thor IRBM strategic missile in England. Entering a new decade, the department was continuously broadening its business base. The reentry systems business, under project manager Mark Morton, was scoring solidly with the Mark III, a second-generation RV for Atlas, Discoverer, Nerve, flight tests on the RVX-2A, and many other programs. The burgeoning space part of the business included work on Advent, OAO, and pre-proposal work on a new meteorological satellite for NASA called Nimbus. With employment pushing 6,000 and 9 locations in Philadelphia, the department was deep into another kind of space program. Boarding a bulldozer in April 1960, General Manager Page broke ground for the Valley Forge Space Technology Center, a $33 million vote of confidence by GE in the future of the business. A future that had begun to pay off even then. It started with Mark III becoming operational and being turned over to the Air Force at Warren Air Force Base. 1 month later, a Mark III launched from Cape Canaveral traveled 9,000 miles on a successful flight to impact the Indian Ocean. Maintaining its mainstay position, MSVD received a contract for the Mark VI reentry vehicle, the third major Air Force missile reentry vehicle to be developed by the department. After 2 years of solid engineering effort pushing the forefront of technology, the Discoverer program team got their reward. The lucky 13th flight was picked off the surface of the sea to become the first object ever recovered from satellite orbit. Followed just 8 days later on August 19th with the air recovery of Discoverer 14, another first. These kinds of successes had earned MSVD a reputation they were building on and adding to every day. The pace was accelerating. Employment surged above 9,000, and the department was active across the entire space and reentry spectrum. A new president had been elected and established a new frontier, tossing the nation's cap over a formidably high technical fence.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
Proposal effort on Apollo began as work on Mark VI, Advent, Discoverer, Nimbus, OAO, TVX, Little John, and other programs continued. Just 6 years old, the department had been a key contributor to the nation's space efforts and was poised and prepared to do more. Company officials visiting Philadelphia and Valley Forge soon saw that the space age had arrived to stay. The geography continued to spread with the needs of the business. People in over 20 states were contributing to important defense and space programs for a host of customers. From Burlington, Vermont to Cape Canaveral, Florida, to Kansas, California, and many places in between, MSVD personnel were part of a period of acceleration and growing accomplishment. Accomplishment recognized with the elevation of the department to division status as the Missile and Space Division, and Hilly Page named as Division General Manager.
Finance in any business and any function for that matter, whether it be finance or marketing, can take an active or a passive role. The finance guy, if he's going to do his job then, has to take all these divergent views, engineering, marketing, manufacturing relations, legal, as they're expressed in terms of dollars. If you're going to be active, then you've got to say, the manufacturing guy's got too much of this, and here's what we ought to do about it. And the marketing guy is this, and here's what we ought to do. The more money, everything. So you're really sitting in there as a real right hand to the general manager.
Advanced Space Projects Department had earlier begun work on an important classified space project, the 206 program. Department General Manager Logan Cowles, a Hermes alumnus, and Jack Katzen, an early 3198 hire, were part of the management team which had to build facilities, hire people, and meet demanding technical program deadlines at the same time. ASPD grew from just 7 people in January '62 to over 2,000 by year end, and 6 months later flew its first spacecraft. GE received a contract for a major supporting role in the Apollo program. Almost 2 decades of experience, as old as Hermes, as new as tomorrow, were strong factors in the award of the NASA 410 contract. While Mark 6 was becoming operational on the Titan II ICBM, proposal work begun the year before on BIOS resulted in the August award of the program to RSD. Spacecraft Department, under new General Manager Roy Beaton, was active on Nimbus, OAO, and studies for Voyager. The Advanced Requirements Planning Operation was carving out its niche in the growing manned space operations business. Investing its talent and resources in this area, 2- and then 4-man cabin tests for up to 30-day missions were conducted inside a full-scale model of a space station. But the big news centered around the award to RSD to develop the Mark 12 reentry vehicle for Minuteman. As work on Mark 6 continued, other proposals were submitted, and major wins helped stabilize employment within the department. Reentry had capped an incredible year by bidding 5 major programs and winning all 5. The division was energetically moving forward in many different directions. Burlington's armament business resurged. And 2 MSD alumni, Roy Beaton and Bill Eaton, headed departments which were added to the division. Beaton as Apollo Systems Department General Manager, Eaton from the Mississippi Test Support Operations. Each had a significant role in the rapidly expanding Apollo program. And Advanced Marketing, under Jack Galt, was extending MSD's presence first to Europe and later to other continents. More than 3 years of study and proposal work on military missions in space culminated in the Manned Orbiting Laboratory Contract Award to MSD in August 1965. Ed Miller, formerly Discoverer Program Manager, was named Department General Manager for the program. MSD was active under contract in almost all phases of the missile and space business. The honor roll ranged from the basic reentry vehicle for all the Air Force ballistic missile weapon systems to scientific and applications satellites, MOLE, and the SNAP-27 nuclear power plant for lunar experiments on the Apollo program. A program whose reality was becoming clearer. Thanks to the Gemini program, followed by the peerless performance of Saturn, the moon was in the same place and a lot closer at the same time. The Valley Forge Space Center continued to attract interested visitors and co-workers. Long-life reliable operations in space had been identified by Page as the best measure of growth and maturity in the business. Already, the 25 minutes in space lab had grown to Discoverer's 4 or 5 days, to 978 days on Nimbus C, a record that later division programs would surpass. Almost 19,000 MSD people, nearly 5 million square feet of space, 6,000 engineers, scientists, the division was still growing, with more new construction underway in the Valley Forge area. The BIOS 2 program accomplished its mission as the RSD Operational Business Section for Mark 12 and Building B of the King of Prussia Technology Center opened their doors. Just before the year ended, Dan Fink, formerly a Deputy Director of Defense Research and Engineering, joined MSD as Manager of Space Systems. 1 month later, Page was named Aerospace Group Executive, and Mark Morton succeeded Page as Division General Manager. With Otto Klima, another Malta and SDPD alumnus leading reentry systems operations, and Dan Fink Space Systems, the division kept pace with the performance standards it had established since its beginning. Linked with Electronic Systems Division in Syracuse and Utica's Aircraft Equipment Division, MSD was part of GE's focus on meeting the nation's changing defense and space needs. Approaching the end of the decade, the Apollo saga built success on success. On May 18th, Apollo 10 accomplished all the steps needed for the manned lunar landing, except the actual landing and takeoff from the lunar surface. GE, under newly named Group Executive Mark Morton, was contributing significantly to Apollo as the government industry team prepared for that greatest adventure. For Apollo, the group was responsible for overall reliability and quality, overall systems engineering support, overall checkout equipment and systems, captive firing and test of Saturn boosters, SNAP-27 nuclear power, ship-to-satellite color TV transmission. More than 6,000 employees in 26 locations were part of that proud history when a promise made just 8 years earlier was kept.
This country rode the first waves of the Industrial Revolution, the first waves of modern invention, and the first wave of nuclear power. And this generation does not intend to founder in the backwash of the coming age of space. We mean to be a part of it. We mean to lead it.
In less than 15 years, the group had hurdled tough technical challenges, ranging from solving the reentry problem to the live color TV super special seen by billions on that July day. The 60s were over. An era of accomplishments across a broad technical spectrum. As the 70s arrived, the continuing challenge was to make that investment pay off.
In the period of the late 60s, as we approached the era of the 70s, we began to realize that the situation wouldn't stay the way it was forever, so we positioned ourselves to take advantage of the wide spectrum of technologies that we're into to apply these space technologies to commercial areas. We were able to operate successfully in the group because we had the ability to blend together and integrate together into a systems approach all of the various technologies that the group was involved in.
The aerospace group is active in almost every segment of our nation's defense and aerospace effort. As I look back in history, we've contributed significantly to the solution of this nation's most difficult technical problems. For over 30 years now, we've carved out our reputation and this position of leadership, a position and reputation that our people build on each and every day. Philadelphia's Reentry and Environmental Systems Division is managed by Otto Klima.
Starting in the mid-60s, the RESD engineers and manufacturing people applied the advanced technologies that were developed for the ICBM reentry vehicle to other areas of national concern. We've designed the Mark 12 and the 12A for the Minuteman, which is the first line of strategic defense for the Air Force. In 1967, we were asked to develop high-quality, permanent houses for the military families at a reduced cost. In studying man's behavior in space, we tried to simulate zero gravity by divers in the ocean. This is about as close as you can simulate it. Developing these techniques to evaluate man's performance in space led us to the Tektite program. It also led us to developing the rebreather for the United States Navy. The rebreather allows man to go to great depths and also stay underwater for a long period of time. Oceaneering asked if we could apply our DEMS, or our diver equivalent maintenance system, to replace the diver using a low light level television set hooked up to our manipulator at the work site, operated by a diver standing on the deck of a ship 1,500 feet above. It's going to be a big help in both oil exploration as well as oil development. Our core business is still strategic reentry vehicles. In the last 20 years, the products that we've developed for the Department of Defense have improved drastically through new technology and the application of this new technology to the product line.
The Space Division, headquartered at our Valley Forge Space Center, is directed by Lee Farnham.
General Electric was there at the very beginning of the space age. We were full participants in the early missions when people were simply trying to find out how to make things work in space. Now we are learning how to apply that technology to bring the benefits of space right back here to Earth, not only for the benefit of this nation, but for all the peoples of the world. I can't think of a single purpose more rewarding to our people, and I think that purpose is reflected in the entire output of the Space Division. If you go back to 1967, this division had 80% of its business in just 2 contracts, MOL and Apollo. In the past several years, we have made significant strides in expanding the core of our space business, which has been space applications. By this, I mean our meteorological programs and our Earth Resources Technology programs. These satellites have had design goals of 6 months to a year, and they are lasting 3, 4, and 5 years. Probably the most rewarding program that this division has had over the years has been Landsat. Landsat-C is the 3rd in the series. These satellites are in space taking images of the Earth, and every 9 days providing coverage of the land mass of the entire Earth. Probably one of the most important things about Landsat is that it has brought the space program home to thousands of scientists and technologists all over the world who are now using data from this satellite on a routine basis. Our newest thrust in the applications area is in our communications satellites area. The first principal success was the winning of the Japanese broadcast satellite, an important program for us because it enabled us to really put into practice all of our latest ideas in what a modern communications satellite should be. The next major win was Discus, the world's most advanced communications satellite. In the military, communication satellites have gone from being helpful adjuncts to where they are now key parts of military operations. We have become leaders in the ground portion of space, not only building stations which receive and process those signals, but providing the equipment which enables users to analyze and use that data in a most efficient way. We are the world's leaders in computer-generated imagery. That is, making pictures generated entirely by computer and used for a variety of purposes, the principal one being for training pilots and navigators. We produce highly realistic images indeed, with weather, haze, lights, and color. We are the leading contractors in providing insulation for the Alaskan pipeline. When the Alaskan oil fields became possible, we realized that it would be necessary to insulate the hot oil from the frozen tundra. We had a lot of insulation technology at that time and put a small team together to see how that technology might be applied. We ran some test equipment up in northern Canada. In an amazingly short time, we were into that business. It finally became large enough to where we opened up a plant in Tacoma, Washington, to manufacture quantities of pipeline and storage tank insulation. We are now one of the leading contractors in this country developing advanced solar energy collection and utilization equipment. We even have one of the earliest contracts for the development of a 2-megawatt windmill, which is another form of environmentally acceptable power. We are using space as an observation platform for our meteorology and Earth resources programs. We're using it as a relay station for our communication satellites. And we're on the threshold of using it for industrial purposes, to do space processing and manufacturing in space. We have applied the talents of our people and our technology to achieve many terrestrial spin-offs, such as solar collectors. I know that in the decades to come, space will teach us much more about our universe, our planet, and ourselves. And we at General Electric will be in the front ranks, applying space progress for the benefits of mankind.
The success we've earned in this business is a direct result of the skill and dedication of our people. Aerospace's honor roll ranges from Hermes to the Space Shuttle, and many, many places in between. From Poseidon beneath the seas to our nuclear power sources now on their way to Jupiter. It includes radars, military and commercial avionics, and a host of technological spin-offs of benefit to all. It's a proud history with new chapters and sometimes books being written every day. The technological tasks of tomorrow will present us with new challenges and opportunities that have always characterized the excitement and the growth of this great aerospace adventure.
NASA's Upper Atmosphere Research Satellite, UARS, is the first mission totally dedicated to investigating change to the upper atmosphere, including processes that lead to ozone depletion. It's the spearhead of NASA's mission to planet Earth and begins a comprehensive study of the upper atmosphere. The layers of the upper atmosphere begin between 7 and 10 miles above the Earth. In the stratosphere and mesosphere is found the ozone layer, which protects life on Earth from the sun's harmful ultraviolet radiation. The discovery of the ozone hole over Antarctica dramatized to the world that substantial environmental change will occur if ozone continues to be depleted. The chemical composition of the upper atmosphere is changed by gases which migrate from the surface of the Earth through the lower atmosphere. Some gases come from vegetation, such as methane from rice paddies and swamps, or from human activities, such as carbon dioxide and nitrogen compounds produced by burning fossil fuels and using fertilizers. Humans produce chlorofluorocarbons, CFCs, which are used as refrigerants and in other industrial uses. CFCs and other gases in the upper atmosphere are broken up by ultraviolet sunlight, freeing atoms which become the catalysts in repeated reactions that destroy thousands of molecules of ozone. If destruction of ozone continues, it will no longer protect Earth from ultraviolet radiation. The impact of these changes on the stratosphere cannot be predicted without more data. So the UARS satellite is being deployed by the Space Shuttle Discovery to systematically study the upper atmosphere. From its vantage point in space, UARS provides near global coverage. This orbit lets instruments distinguish between short-term daily and long-term seasonal effects, and permits a view of ozone depletion over the poles. The UARS observatory includes 10 instruments. A total of 19 investigations explore the complex interactions in the upper atmosphere. UARS instruments will provide the first comprehensive data of the interactions of atmospheric chemistry, wind dynamics, and solar radiation.
is very different today than it was in 1971. The Cold War was raging. Troops marched in Vietnam. NASA led the space race, sending Apollo 15 to the moon. 30 years ago, the United States challenged a team of aerospace companies to take a quantum leap in space ground systems to safeguard our nation's security. Their endeavors would lay the foundation that would change the face of the free world as we know it. And along the way, a company was born, a company called Management and Data Systems.
In 1971, we won the core program, which was a classified activity, and that was really the foundation of M&DS.
We competed with Lockheed, North American, Boeing, and it was an incredible time of 16-hour days, 7 days a week.
How did we deal with those pressures? We worked an inordinate number of hours, neglected our families, smoked too much. But basically, I think we trusted one another.
To meet the challenge, we brought in breakfast, lunch, dinner, and cots.
First, we can thank Matt Kramer for our drive for pride in everything we do. Bill Fucus taught us what are the real essentials of managing a business. John Walton established a high standard for performance, and Collard Knoll gave us a strong example of what job ownership and commitment are all about.
What we were working on was strongly in the national interest, and that this achievement would aid in the establishment of world peace. The 1980s, for me, had to do with the breakout of our business into the unclassified world and to new customers. And most significantly was our win of the second TDRS ground terminal.
The second TDRS ground terminal was a tremendous achievement and demonstrated that we could step out of our core boundaries and perform for NASA and the country.
That gave us our first opportunity to export our significant system engineering and software development skills.
As we started to expand away from the core program, I think major steps were taken, both with the Defense Mapping Agency as well as with the win of the Defense Dissemination System.
Patriotism was a very strong component. It allowed people to endure the pressures that were placed on them. And if it wasn't for the self-motivation associated with the patriotic spirit, we would not have achieved what we did.
The news that the Berlin Wall came down and the Cold War was over, and we had done that without loss of a single young American life, just made me feel wonderful.
In the 90s, the delivery of RMS and the win of the Program 400 were the most significant accomplishments.
I think the name change made a difference. It indicated that we were broadening our perspective. Transitioning to Lockheed Martin made us the largest player in the aerospace industry. I don't think we really anticipated the speed of the information age explosion, but we were able to take advantage of it across the board. I think in the late 90s, we added a significant capability with the addition of Western Development Labs, Goodyear in Arizona, and several other organizations. It really made M&DS a whole that was greater than its parts.
Working at M&DS gave me an opportunity to do three things that are very important to me. One is to work on good technical work, two, to work with a great team, and three, to serve my country.
Engineering excellence, commitment to the customer, and integrity have stayed constant through 30 years.
If I had to come up with one word, it would have to be that I was blessed to have crossed paths with this business.